This is section 9.1, the square root property and completing the square. What we're going to be doing here is we're going to be solving quadratic equations. These were things like ax squared plus bx plus c is equal to 0. Now we have solved these before. What we did was we solved them by factoring. We got a 0 on one side, we factored the left, and then we set each factor equal to 0 when we were done. That's great when it works. There are things that cannot be factored, and so they cannot be worked that way. Okay? It is also possible that we get answers that are complex or are irrational, that they still have a square root in them, and those are things that we couldn't have had before. What we're going to learn in this section are two properties or two methods for solving a quadratic that doesn't necessarily factor. So these two methods will give us those other kinds of answers. Okay. Now the square root property is probably the easiest of all these other methods. What we're looking for is a quadratic that is specifically in this form, where you have something squared. It doesn't have to be just x. It could be a lot more complex than just x. But if you get something squared equal to a number. When we have that, we can basically take the square root of both sides. But when we do that, we have to put a plus or minus on the other side. Because if you recall the section when we did the square root of x squared and we had to use absolute values on it, it's that same kind of reason here. We get generally two answers. Okay? So let's try one. I want to solve t squared is equal to 17. If I tried to do this using the methods we've had before, I would have moved the 17 over. I would have t squared minus 17 equals 0. And then I would try to factor this, but this is prime. So I cannot solve it by factoring. I do have something squared equal to a number, so I'm going to take the square root of both sides, but I have to remember to plug in that plus or minus. So what I get from this is that t is equal to either plus or minus the square root of 17. Now, as always, if this square root simplified any, I would be doing that, but 17 is a prime number, so this doesn't simplify. Remember that if you have a square, you should expect to have two answers, and we do. We have a negative version and a positive version. I really want you, when you get more than one answer, to split it up in set notation. This is the most proper way to give your answer anyway, but if you develop this habit of writing it down like this, you will avoid the most common mistake, which is to leave off the plus or minus. Because you know you should have two answers, and if you don't put that in there, you're only going to have one, and that should prompt you to go back and look. Okay? So let's try 3n squared minus 72 is equal to 0. Now, what we're looking for here, I do not have something squared equal to a number, but it won't be difficult to solve this for an n. I don't have any other n's in there. I can solve it for an n squared, So to do that, we're going to add 72 to both sides. 3n squared is equal to 72. Now let's divide both sides by a 3. And we get n squared is equal to 24. Okay, now we can take the square root of both sides because I have something squared equal to a number. And when I do that, I put in a plus or minus sign right here. So I have n is equal to plus or minus the square root of 24. Now, we should probably be able to simplify the square root of 24, and this is the same prime factorization sheet we've been using all along. We have 24 right in here, so if you cover up the 48, you have a pair of 2's, and then you have a 6 still inside, so it's going to be 2 square root of 6. So plus or minus 2 square root of 6. So my two answers are negative 2 square root 6 and positive 2 square root 6. You may be wondering if you have to put the minus version first, and you do not. It doesn't really matter in a set which way it goes, but since so many of our things do require it to be in order, this is my own habit. That way I don't have to remember which is which. Okay. All right, so both of these examples gave us answers that we would not have been able to get if we were just using factoring, because neither of these would factor. This one, it doesn't look like it would factor, but we're going to actually be able to see that we could have factored this. It would just been a lot more trouble. Okay, so if I look at this, I have something squared. It's more complicated something than what we've been dealing with, but I do still have something squared equal to a number. And that means I can take the square root of both sides. But I have to put in a plus or minus over here. Okay? Well, if you take the square root of something squared, you just get that something. So this is going to be t plus 8 is equal to plus or minus. We can actually calculate the square root of 9. So that's 3. Okay? Now, technically I have two equations here. I have t plus 8 equal to negative 3, and I have t plus 8 equal to positive 3. You can do more algebra and then just work the arithmetic at the very end. If I split this up into two problems, I would have to move the 8 over to this side in both of them. So let's go ahead and do that. So I get t is equal to, I could do plus or minus 3 minus 8, but most people find it easier to put the number in front of the plus or minus, just because it's easier for most people to calculate. It doesn't look so confusing. Okay? So now that I have my t solved for a number, I just need to calculate what these two things are. So t is equal to either negative 8 minus 3, or t is equal to negative 8 plus 3. So t is equal to negative 11, or t is equal to negative 5. We got regular numbers here. That tells me that this thing could have been solved using factoring. To do that, and you cannot pay attention to this part if you don't want to pay attention to it, I would have needed to square this out, which would be t squared plus 16t plus 64 is equal to 9. And then I would have had to move the 9 over here, and then I would have had to factor, and then I would have gotten these two answers. Okay, it would have taken a while, but you could have done that. It's just hard to see when it's in this form. It's much easier to see that the square root property will work, and you can get your answers more quickly. Now, like I did say, you should write your answers in set notation. So I have negative 11 and negative 5 as my two answers. Okay. So let's go here. I have t plus, get it on the screen. T plus 5 squared is equal to 48. Again, I have something squared is equal to a number, so I can take the square root of both sides. If I remember to put in a plus or minus over here. This gives me t plus 5 is equal to plus or minus the square root of 48. And the square root of 48 we have right here. It's 2 times 2 is 4. 4 square roots of 3. Since I still have a square root in it, that tells me I would not have been able to factor this thing. Okay, now we want to solve for t. So I'm going to subtract 5 from both sides, and I'm going to put that in front of the plus or minus, so that I get t is equal to negative 5 plus or minus 4 square root 3. If we were allowed to combine these, I would, but since this one doesn't have a square root, we cannot combine them. So our two answers are negative 5 minus 4 square root 3 and negative 5 plus 4 square root 3. If you want to check these answers, you can do that using these calculators. What I'm going to do is I'm just going to take one of them, and when you have a problem like this, if one of them works, the other one will as well. So I'm going to calculate negative 5 plus 4 times the square root of 3. Okay, now I'm going to store this in memory. Your memory button is right here, STO for store. If I hit that, it's going to take that answer and it's going to store it in wherever I tell it to store it. Here's your variable button. I'm going to hit that once. It's going to give me an X. So from now on, if I just type in X, if I just hit that X button again, it's going to bring up that value. Okay, so what I'm going to do here is I'm going to plug it in right here. I have open parentheses. I'm going to use X because you know the variable actual letter doesn't matter when you're checking. Equals, and I'm going to square this, and I should get 48. And I do, so it's correct. Since I did one of them, the other one will work. You could also find a decimal approximation and try plugging that in. You will not get exactly 48, but you should get close enough to 48 that you're convinced that it's correct. Okay. One more of these square root problems. Okay, I have r minus 5 squared is equal to negative 3. I have something squared equal to a number. So I take the square root of both sides, putting a plus or minus on the number. So I have r minus 5 is equal to plus or minus the square root of negative 3, since there's a negative on the inside and I needs to come out. And 3 is a prime number, so it's going to be stuck inside. Okay, now I'm going to add 5 to both sides. So I get r is equal to 5 plus or minus I square root of 3. We're not allowed to combine these. So your answers are 5 minus I square root 3 and 5 plus I square root 3.